subscribe to our YouTube channel, as well as to leave us a comment if you like this type of content, if you'd like to see some other brands or anything different when it comes to manufacturing automation. Please do so in the comments section down below. And so the last thing I do want to mention, because I know this question always comes up, is how can you follow along with these tutorials and where can you download the files? So there's going to be two files in this specific scenario. The first one being the PLC file and the second one being the factory IO scene. So at this point, what you can do is, if we look at the controller name, you'll notice that it's going to be Solus PLC underscore Vlad underscore CGL1, and that is in our Studio 5000 environment. If you go on the web in your browser and type in github.com/vromanov89/Solus development, you will be brought to a GitHub page which contains all the technical files required for you to follow along. And you will notice that there's going to be a number of different files. You can download all kinds of software that I've used in the past in the tutorials and at any different point in time. That being said, you need to scroll down and find the exact name of the controller that we are programming this time, and that's going to be, once again, Solus PLC underscore Vlad underscore CGL1, and the file extension for Studio 5000 files is going to be .acd. So you can click this file and you will be brought to a blank page. That's because GitHub doesn't necessarily showcase PLC files. That is a whole separate discussion. That being said, at this time, you can download the latest file by clicking on this button right here, and you will notice that it will save just that one file in .acd format, which you can then open in RSLogix or Studio 5000. If you want to work in the exact same revision, you'll need a controller at that firmware, but you can always switch the file to a latest or earliest revision if you choose to do so. The other thing I want to mention is that you can also click on this history button and you will get different commits. I will try and label them in reference to the lectures that we will be performing. So keep an eye out on this. It will say lecture 1, lecture 2, lecture 3, and so forth, as well as the title of the lecture to make it easier for you to find the right file. In the previous lecture, we created a new scene. I wanted to go through that process again, so we are back to the main page. We can simply press on new and we will be brought to the same environment we saw last time. Once again, I like to see the first person camera, so I'm going to switch into that mode right away. And you will notice that at this point, I can walk around this warehouse space. Before we edit this scene, let's figure out how we can customize and then bring in the tags from our controller. So remember that if we click on File, Drivers, and we go into our controller, as I press connect, I will be shown that 4 of my tags are configured. What I want to do is disconnect, and if you're currently in this state, I want to navigate into configuration, and let's explore the Boolean inputs, float inputs, as well as integer inputs a little bit more. So the prefix is going to be custom to you. So just to make sure that we can change this, I'm going to label this as Solus PLC input, Solus PLC output. Make sure that we have the right amount of underscores. I'm going to also change this, so Solus PLC underscore, and let's also make sure that this is going to be a Boolean, so Solus PLC underscore B underscore input, and we can change the name. Once again, you need to create your own convention. There is no right or wrong answer when it comes to this. So Solus PLC F out int, and then Solus PLC int out. I'm going to save this by going back to the previous configuration. And at this point, you'll notice that the PLC has updated the tags. Now, if we connect to the PLC, once again, I'm going to get the exact same warning signs that we saw last time for most of our tags except the top 4. Now, in order to resolve this, you can follow the label of the alarm, which says that the tag does not exist. So what I need to do is, and I like to do this a little bit easier, so I'm going to copy the entire name. So this is going to be my input. Go back here. If I navigate into Studio 5000, I now need to create the matching tags of the right type so that Factory IO can pull them in. So I'm going to navigate into Edit Tags. These are going to be controller scoped tags. Once again, if we select controller tags underneath our controller name, and then go into Edit Tags, I can start by typing in the name, And here, this is going to start with a 0. And the data type, remember, so this is going to be a Boolean based on the name. I need to make sure that this is of type bool. Once I press enter, I can navigate back to factory IO, and you'll notice that the alarm is still there. And what you need to do is disconnect from the PLC and then reconnect to the PLC, and that will update the tag. And this was one of the reasons why the auto update doesn't necessarily work. You need to disconnect and reconnect to make sure that everything is working as expected. So at this point in time, let's create a few more tags. I can go back to Studio 5000. Here I'm going to press 1. This is going to be a Boolean. I can then press 2, create a Boolean, and we'll see how we can use the integers faster to avoid creating a tag line by line. But in case of this tutorial, or for the purposes of this tutorial, all we're going to do is create a few tags, so that shouldn't take too long. So I'm going to leave that at 6 tags. I believe that is perfectly fine. I'm also going to create a few output tags. So once again, just to validate, the tag is going to be Solus PLC underscore out 0, and that's actually not what I want. So I want to make sure there is a B over here. So let's add that in place, make sure that everything is typed correctly. I'm going to copy this into my clipboard, make sure that everything is correct on this side. Back to Studio 5000, paste this in, start with 0. Remember, if the names do not match, this is not going to work. So we need to make sure that the tag names are exactly as they are specified on both ends. So in Factory IO, as well as Studio 5000. So let's just create 4 of these. Perfect. So let's go back to Factory IO. Once again, I need to disconnect and reconnect to my controller, and you'll notice the tags that we've just created have been displayed or are displayed now inside of this driver. Next, we have the floats as well as the integers. So I believe that the integer is going to be a good place to start. Let's navigate back into the integers just to double check. So here I'm going to copy this int tag name, and I'm going to create 2 of them. So this is going to be 0. Remember to change this to integer because it's going to be 16 bits instead of 32 like the double integer. Good. Let's double check the outputs. And so on the output side, I'm going to create 2 of them as well. Excellent. And so the last tags that we need to take care of are going to be floats. Now, the float type inside of Studio 5000 or RSLogix 5000 is going to be a real. So here, I'm going to paste this in. I'm going to put a 0, and this is going to be real. And similarly, the output, again, let's make sure that we copy this correctly. Solus PLC output, and this is going to be 0. This is going to be real. Good. And let's validate that everything is coming in as we expect. So we're going to disconnect and reconnect to the PLC. And you'll notice that all the tags we've created are currently being brought into the driver. Now that we have some tags, how can we use them in our design? So I'm going to press on this back arrow. I'm going to be brought back to the warehouse environment. And at this point, we need to create a few elements in order to represent the tags that we want to tie into the PLC with physical elements. So you'll notice on the right-hand side, there's going to be a number of different things or objects you can put in that you would normally see in a production environment. So those are going to be safety curtains, they're going to be pallets, they're going to be motors, alarms, stack lights. And so one thing that we can do is create an electrical panel. So all this really is a box, and you'll notice that as I drag it into the environment, it's going to allow me to place, and as I continue to use WASD keys, I can walk around and place it wherever I need. I'm going to let go of the panel right there, and as you can see, it's going to allow me to once again reposition if I grab onto it. However, I do need to turn the panel, so I'm going to right-click on my mouse, and here you'll notice that there's going to be different ways to rotate the element. So I can rotate it this way via the Z-axis, and that is exactly what I want. You can also pivot it on its side, or you can pivot it towards yourself. Now, what we need to do is we want to place it against the wall, because in my mind, a panel is either going to be mounted on a piece of machinery or it's going to be placed on the wall. And so at this point, I want to right click the panel. I want to select a vertical translation, and you'll notice that as I continue to drag my mouse, I can raise the panel off the ground. As soon as I let go, it will be stuck to that specific location. And I personally believe that a panel should not be laying on the floor. So this is a decent representation of what a panel would look like in a manufacturing environment. Now, when it comes to factory I/O, you're going to find a lot of passive elements, and a panel is one of them. So there's no way to tie in this panel into your PLC. It is just an object that is represented in the 3D world. That being said, you will notice that there's going to be lights, switches, motors, conveyors, and other elements that will be tied to the PLC. And so at this point, I want to be able to start and stop my system. I also want to get some indicator lights. So I want the system or factory I/O to tell me the system is running or the system is stopped. And I can do that with light indicators. So what I'm going to do is I'm going to drag this indicator out, and if you don't see it immediately, it's because it's been dragged out on the floor. So you'll notice it is being positioned all the way at the bottom. If I let go and then navigate around and zoom in just a little bit, you'll notice that the button is definitely there. Now we need to do a couple of translations again, as I've done in the past. So we can rotate this button this way so that we can position that on our panel. I can then right click once again. I want to do a vertical translation. I'm going to raise it all the way up. I'm going to let go and see how it looks. Normally, my buttons want to be on the surface of the panel. I've never seen a button float in the air. So what I'm going to do at this point is I'm going to simply click and position it on top of the panel. As you can see, it's very nice and neat. I like to have status lights all the way on the top. It seems weird to have it at the bottom. So I'm going to once again vertically translate. And let's say that is going to stay right there. That looks, I think, decent. I'm then going to repeat the same procedure with the red light. So once again, I'm going to drag it out. I'm going to turn it towards the panel. I'm going to use vertical translation to position it roughly where I need it to go. I'm going to bring it on to the panel, vertical translate once again, let go. And we have two indicator lights. So that's pretty neat. We can start tying in some of our code. To create a link between the tags in factory I/O and our PLC, we need to go back to the driver, so File, Drivers, and here you will notice that the actuators section, which previously only contained 4 of those tags, if you were paying attention, now has 2 extra tags, one for our light indicator green and one for our light indicator red. So what needs to happen now is we need to assign them to a tag on the PLC side. So if I bring in this light indicator, you will notice that I can drop them in any of these sections on the output side. Pay attention to what factory I/O tells you, because I cannot drop this as an input. An LED or a light indicator can only be an output for the PLC. So therefore, I can only drop them inside of the output tags, including the integers, but that's not going to function as we would expect. So I'm going to also bring in the light indicator red into my second tag. And so just to double check, this is going to be output 0 for green and output number 1 for red. If we go back to our scene, you'll notice that nothing has really changed. And the way we can view the current state of the tags is by pressing this play button. So you will notice that we're going to be entering run mode. And so in run mode, we're not going to be able to add new elements to factory I/O, but we're going to be able to interact with the elements inside of the environment. And we'll see how this gets a bit more complex as we move forward. That being said, at this time, all we have are indicators, and you'll notice that both of them are off. How can we toggle one of these indicators? If I go back to my Studio 5000 environment, if I monitor my tags, remember that we're looking at Solus PLC Boolean output 0 and 1. So if I put a 1 inside of my 0, I would expect the green light to come on. Let's validate if that's true. And as you can see, as we would expect, this light is now green. On the next light, if we go back to Studio 5000 and we press this 1, toggle it to a high, you'll notice that the light is also turned on. So just like that, we've actuated two tags inside of Factory IO through our PLC. And as you can imagine, we can write all sorts of logic that will behave as you would expect in the real world inside of this simulated environment. And so to save us just a little bit of time, I placed a start and a stop push button on our panel and saved you the time to watch me do it. Now, there's going to be a distinction between the indicators and the push button, and that is the fact that the indicator is only going to show us what's going on with a tag, while the push button is going to be able to toggle a tag on the PLC input side. So here, what needs to happen, if we go back into File, Drivers, we need to tie in on the sensor side into our PLC. So notice that there's going to be sensors, and those are going to be inputs, and there's going to be actuators, and those are going to be outputs from the PLC standpoint. And so my start push button can go into input number 0, and my stop push button can go into input number 1. And so for the purposes of some of these tutorials, let's go into the task called tutorials. And here where I'm going to create a new routine, I'm going to label this _03 underscore Factory IO sim. That's going to be in ladder logic diagram. We might explore other languages in the future. I'm going to press on OK. And so at this point, I can create some fairly basic logic to interface with my push buttons and the indicator lights. So the first step is I'm going to create an XIC as well as an XIO just to test the application. So in this case, remember, if we go back to Factory IO, and I typically switch between the two softwares, you'll notice start button 0, Solus PLC _B _ input 0, stop push button _1, and then the outputs are going to be the indicator lights. And so what I like to typically do is I can start by typing in the name, but you'll notice that it becomes confusing to know exactly which tag this is. So we can do this in multiple ways. There's going to be tag aliasing, but one of the easiest ways is going to be by adding a description. So we can also use the shortcut, as you can see, Control D. I can say that this is going to be my start push button, so start PB, and I'm going to exit this window. So you'll notice that above I'll have a start push button, and then on my OTE side, just to make it easier to see, I'm going to increase the view by holding down the Control key and scrolling on my mouse wheel. I'm going to put this Solus PLC. Notice that this is not an input. This is going to be out 0. And here, just as we did before, I'm going to right click and I'm going to edit the description. And this is going to be green indicator. So now that we have the logic in place, let's make sure that we finalize all the edits for this first push button and double check what we can do in Factory IO. So in Factory IO, I always like to disconnect and reconnect to the PLC for the reasons that I've mentioned before when I make any changes. If I go back to our panel just as it was before, we can walk around and we can see what's going on with our element. In order to interact with the panel as we had done before, we need to once again enter the run mode. And so at this point in time, all we need to do is press the start push button, and as long as I maintain the button to be down, you'll notice that the indicator is going to energize. So that's the most basic example we can see in order to interact with some of the elements. Let's go back to Studio 5000 and write just a slightly more complicated piece of code in order to learn a little bit more of PLC programming. So here I have my start push button. I would like to latch in the system when I do so. So I'm going to double click on my rung. And so what I'm going to put here is another, it's going to be an XIC because it will be a stop push button. And so here I can just double click the name and I can paste that in, simply change it to a 1. And that way it makes it easier for me to understand which tag this is going to be. I'm going to right click and I'm going to edit the description. So this is going to be the stop push button. And we're going to change that label. And so if the start push button has been pressed, we want to be able to branch around this, put this OTE in place here, and change that, of course, to an XIC. And this stop push button is going to essentially reset the indicator, but we also need a second rung because I want to see when the system is stopped as indicated by the red indicator. So if the green indicator is off, and this is going to be an XIO, here I'm going to type in an OTE, which is going to toggle the other output, and that's going to be output 1. And in this case, once again, we're going to edit the description, which is going to be red indicator. And you'll see the logic in just a moment. I'm going to compile everything. I'm going to press on yes. So this is as basic as you can get. This is an example of a system or motor starter. And if we go back to factory IO, you'll notice that we're still in play mode. It seems that the tags are reading okay. So what I need to do is I need to press the start button. You'll notice that if I let go, the green LED no longer goes off. So the system stays running. If I press the stop button, it's going to stop my system and it's going to give me the right indicator when the system is stopped. So that's going to be it for this video. As I've mentioned earlier, you can download this version of the PLC code on the GitHub page. I will also save the scene by pressing on File, and I believe that the scene is already created, so it has been saved. You will also be able to download the scene in order to practice on your own. And in the next videos, we're going to be doing something a little bit more complex.